this is 5.2, part 2. Just kind of recapping and finishing off, Mr. O'Donnell, the adding and subtracting polynomials. So it's a pretty simple section, right? You would agree that yesterday was pretty simple, Mr. O'Donnell? Yeah. Now, do you have a graphing calculator over there? Because that's going to pay dividends today, okay? All right, so let me go through this and kind of explain it to you to the best of my ability. So as you guys move throughout your career here at Pencrest, you're going to be given opportunities to take certain classes. One of them is physics. Now, I know it's not going to, kind of be for everybody, but, some of you might want to take physics. And in physics, they use a type of equation. They call it down there called a Vavavadat. That's what they called it when I was here. And basically what it is it's a function that relates like velocity and time, or distance and time, or acceleration and time. So up here we have an equation. This is a distance equation, okay? And it's relating distance to time, okay? So after so many seconds or so many minutes, I can find a position of a function. And Garrett, this will sort of make some sense to you, okay, because of basketball, and I'll explain it to you through that, all right? So you're not doing these calculations in basketball, but it kind of like goes into play a little bit, okay? So up here, we have the height of whatever we're throwing or tossing is equal to this equation, which is negative 16t squared plus v naught t plus s naught. Now, all of these things kind of have meanings. That naught means like initial. So like v naught stands for initial velocity and s naught stands for initial height. Now, Garrett, I said this kind of relates a little bit to you. Now, when you shoot a basketball, right, it goes in an arc. It goes up and then it comes down. And basketballs are traveling in this parabolic pathway, meaning they go up, and believe it or not, Garrett, the ball stops for a second rising, not moving left to right, but rising for a second, and then it comes back down. And the reason why I'm relating this to you is you know when that ball leaves your hand if it's going in or not, right? You have that feeling. If it comes off your finger the wrong way, it's going to have a different spin. Or if you're shooting it too hard, well, then it's going to hit off the backboard and bounce out, correct? Like, you know that feeling. So you're not calculating this stuff, but you just have that muscle memory that like, oh, I'm this far away. The ball needs to hit this certain height and then come back down. And also they talk about, I don't know if you've ever watched sports science, but they talk about certain people, the reason why they jump is because it actually makes the net appear bigger, even though it's not, but the angle that ball is traveling down is going to enter at a different angle. You need to watch it. If you've never watched it, watch Sports Science and look at the famous jump shots. They talk about it. One of them was Jeremy Lin. Jagger? I do not have a pencil, but the pencil sharpener is to your left. No, stop. Just literally right there. You're the man. All right, so up here, this is all of this information. And the reason why we do this is because we can gather stuff, okay? I know if I throw something at a certain velocity, I can predict where it's at and I can gather information. So up here, what you guys need to know is the directions of up and to the right are considered positive directions, and down and to the left are considered negative. So when I throw an object up, it's going to have a positive velocity. If I throw it down, it's going to have a negative velocity. So I'm on top of the Eiffel Tower, and I throw a ball up in the air. So my initial height is 984 feet, okay, off of the ground. And I throw it up with an initial velocity of 40 feet per second. This is my equation. So what I want you guys to do is I want you guys to all hit y equals on your graphing calculator. And I want you to type that in. Now, here's the funny thing. You don't have a T button, but you do have an X button. So let's go ahead and type it in as X. So you're going to type in negative 16x squared plus 40x plus 984. Okay. And then we're not going to hit the graph, but we're going to hit second graph, which brings up the table. Now you're going to have this table. Let me pull up mine. Okay. And it's going to have a bunch of numbers on it. And we can use that table to determine what the value of my function is. So I enter in my equation. It's right there in the y equals. And now I'm going to hit second graph to bring up the table. And it's right here. Now, this just made this whole problem very simple. I want to know what is the height of the ball after 1 second. So that just means I'm going to replace the t with 1. So I have negative 16 times 1 squared plus 40 times 1 plus 984. And what did you get for h of 1? 1008. And all it's doing is this. It's plugging in 1 into that equation, and then it's spitting this out. Now, that was pretty easy to do, correct, Owen? And the reason why I want to bring this little tidbit up is because now instead of plugging in 5 into your equation, I can actually just scroll down a few. So Jagger, what did you get for h of 5? Okay, so did you enter in your equation under y equals? All right, so that's where we're entering it. Okay, and of course, my technology is still breaking. Can't win, right? And Mr. O'Donnell, what did you get for h of 5?
Yeah, it's all messed up on my card. I got 784.
It is 784. Right, Owen, that's what you got? Yeah. 784. Maggie, you got 784? I don't know. It just started breaking to that. And h of 9. Garrett, what did you get for h of 9 if you scroll down? What was it? Was it 48? So Garrett, we were working, and this is a big problem, not calling you out on it. But in math class, okay, what we have to make sure is that our calculator is in the right mode. Now, we were in scientific mode, right? So if your calculator is still in scientific mode, you need to put it back in normal and then go back in, okay? And you got a bunch of floating decimals, so I'm going to take them off to make it a little bit easier for you. Okay. And what did you get now for 9? 48. Okay. So Garrett, the only reason why I bring that up to you is because I had physics, then I had math class when I was here, and I was a junior. And I had a physics test, and we dealt in degrees. And I had a math test following it, and we were dealing with radians. And I took my entire test in degrees, and it did not go well for me. So we have to make sure our calculators are in the right function. And if it's not, Garrett, you just let me know. If you get a weird answer, you just let me know. Why? Well, So certain parts of the world will use degrees. America uses degrees, okay? And radians are kind of like, you know, what Europeans use. So you know how we have pounds and kilograms? Same thing. Why don't we all just use the same measurements? I don't know. They both have their benefits, okay? Degrees are something that are common to us. It's easy, and it's like easy to calculate in our head. Radians are just like your full circle. It's just talking about like part of your circle, of the unit circle. So a full circle is considered 2 pi. So if you're doing 360, which is a full circle, 2 pi and 360 are equivalent. Good question. I wish I had a better answer than, you know, part of the world uses radians and part uses degrees. But it's what we're used to. All right. So let's go to the next one. This is talking about a free-falling object. And this is an object that we're throwing down off of the Empire State Building. Kind of think of a penny, Owen. Have you ever thrown a penny off of the Empire State Building?
Yeah.
Oh, and that could kill somebody. No, I'm joking. It actually just bounces off. Hurts a little bit, but it just bounces off. So, Owen, I'm throwing a penny off of the Empire State Building. I'm throwing it down at an average velocity of negative 15 feet per second. So I would like you to take this into your calculator. Did you already do that? All right. So while you're doing that, I'm going to attempt to align my board and then answer these questions. So everybody go ahead and type that in, and I'll be looking, I believe the numbers are 1, 5, and 7. Oop, 1, 4, and 7. So each of 1, each of 4, and each of 7. Emily, Greg, what did you get for each of 1?
Hang on.
Are you doing it right now?
Yeah, is it 1051? Or am I wrong?
So I think you have a sign wrong. Do you have negative 16t squared?
Oh wait, I did positive 16.
Yeah, that's why you got 1051. So put that in as a negative. Let me know when you get the answer.
I think it says the same thing for some reason, but I don't know.
All right, so let's see. So you have negative 16x squared minus 15x plus 1050, right?
Yeah.
And then we're going to go over here to the table. And then did you get 1019? If you didn't, check your equation.
I'll turn my thing off and back on. I don't think it refreshed for some reason.
Okay.
Now it says 1019.
All right. So we should get 1019. All right. Let's go to Mega. What did you get for H is 4? You can type it in the chat if you would like, or you can say it out loud. All right. What about Caitlin? What did you got?
734.
Owen, is that what you got? 734?
For 4?
Yeah.
We have 5.
All right, well, let's see. 4, I got 734. Okay, it's okay. I did say 5 when I was going through it. All right, it's 4. All right, and the last one, Marcus, what did you got? Marcus? All right, moving on to Mr. Kitchen. Ben, what did you got? Tough crowd. Tough crowd. Mark. No, it pops up here. All right, Jagger, what did you got? 161. 161. Okay. And this is all in feet, so it's nice and easy. Now, a little tougher of a problem. Holiday spending. Thousands of US adults were surveyed about holiday spending. The amount they planned paid on spending in dollars from 2004 to 2007 can be modeled by P equals 3.5 T squared minus 85.5 T plus 1288. I don't know why or how they came up with this, but they did, okay? And they said the amount they actually spent was T squared minus 62.4 T plus 1207. Now, from 4 to 7 corresponds to the years from 2004 to 2007. And it says determine the polynomial that represents the amount saved per year. Now, Maggie, let's say you go out to, which store do you shop at? Lunchbox? You know about Lunchbox? Oh, Lauren had me figure the Lunchbox in Christiana. Which store do you typically shop at? Yeah, I think so. All right, let's say we go to Target. And you plan on getting, what are you getting at Target? The book. So you do your research, and the book costs $20. You go to Amazon, you hit, or not Amazon, you go to Target, you go to checkout, and they say, oh, $16, right? You plan to spend 20, but you actually spent 16. How can I determine how much money I saved? What would I do with the 20 and 16? Yeah, find the difference. So up here, when I have my planned function and I have my actual function, I'm just going to subtract the two. So I'm just going to do the planned minus the actual. Okay? So the planned is 3.5 T squared minus 85.5 T plus 1288. And as Maggie said, I am going to subtract my actual, which is T squared minus 62.4 T plus 1207. Now, from yesterday, I talked about how when we subtract, we add the opposite. So I'm actually going to do one more step, and I'm going to do 3.5 T squared minus 85.5 T plus 1288 minus, and I'm going to change the sign of everything in that second equation. So minus T squared plus 62.4 T minus 1207. And I'll give you a second. All right, so now what I'm going to do is I'm going to group together my T squareds. So 3.5 T squared minus T squared, that's going to be 2.5 T squared. And then I'm going to go ahead and I'm going to group together my T's. That's going to give me, all right, so that'll be what, minus 23.1 Did I get that right? So minus 23.1 t. And then I'm going to combine my constants. So 1288 minus 1207 is going to be 81. All right. Fair enough. Now it says use this polynomial. So let's see. We're going to use this polynomial down here. Okay. So let me get rid of that and that. So this polynomial, let's get rid of all of this. Uh-oh. Oh no, I tried to be fancy. What was this in the middle, Maggie?
Minus 23.1.
And this was 81. Now it says use this polynomial to find the amount saved in 2005. Well, up top we had 2004 corresponding to 4, so 2005 corresponds to what, Owen? 5. So I'm just going to plug 5 in for this. All right, so I'm going to have 2.5 times 25. Well, 25 times 25 is what? 625. So it's going to be what? 62.5? Is that right? 25 times 2.5? It's 62.5? Hold on. And then negative 23.1 times 5 is going to be 5, 15, 1. Negative 115.5 plus 81. So 81 and 62, that's 143.5. So 43 minus 15, we're looking at 28.
Yeah, that's all I
28. They save $28. Woo. All right.